Right, we are trying to find an analytic function f of z equals u of x and y plus I v of x and y for the function u of x and y equals cosine x cos y. We begin as follows, so we let f of z be equal to u of x and y plus I v of x and y and u of x and y, which equals the cosine of x cos y. Right, so if this is the case, we remember what we call the Cauchy-Riemann equations. Cauchy-Riemann equations. What are the Cauchy-Riemann equations? Okay, there are specific Cauchy-Riemann equations that we use here. We use u sub x, the partial derivative of u with respect to x must be equal to the partial derivative of y, or rather v with respect to y. And the partial derivative of u with respect to y must be the negative of the partial derivative of v with respect to x. Now, what do we do with these things? What do we do with these things? We proceed and say thus. Right, we are given u as a function of x and y, which equals cosine x cos y. And so, what is this? Okay, this implies that u sub x, the partial derivative of u with respect to x. What is it? What is it? So we have the partial derivative of u with respect to x. Right, the derivative of the cosine function is the negative sine of x, cos y. But right, and we have u sub y, the partial derivative of u with respect to y, which is cosine x, the hyperbolic sine of y, like so. So we found u sub x and u sub y. Okay, now we make the following observation and say hence u sub x is v sub y. What is u sub x? It is exactly this. So u sub x is minus the trigonometric sine of x cos y. And v sub y must be equal to v sub y. Right. So now what do we do with this? What do we do with this? Okay, these has further implications upon integration. Integration with respect to y would give v of x and y, which equals, okay, with respect to y, this is going to be the hyperbolic sine of y. So in other words, this becomes minus, can just write v only. It's okay, doesn't matter. Okay, which becomes the sine of x, the hyperbolic sine of y, plus phi of x, like this, like this. So because if you're integrating with respect to y, it means that x is constant. That is why we are adding a constant that is the function phi of x constant. Right, now, after having obtained these, we proceed as follows. Right, we proceed as follows and say v sub x. So with respect to x, the derivative of the sine becomes the cosine of x. Plus the derivative of phi with respect to x. Like this. Like that. We proceed to the next to solve this. So we have that v sub x equals minus cosine x hyperbolic sine y plus the partial derivative of phi with respect to x. Right, we wrote that v sub x equals minus cosine x hyperbolic sine of y. Partial phi partial x. Like this. Now, u sub y is actually equal to minus v sub x, and this is what we call the Cauchy-Riemann equation. Cauchy-Riemann equation. So which means, what is u sub y? U sub y, let's check. Right, we got that actually u sub y is cosine x hyperbolic sine y. Cosine x hyperbolic sine y. So that's what we write. So it is exactly cosine x hyperbolic sine y, which equals minus. What is v sub x? Is minus cosine x hyperbolic sine y plus partial phi partial x. Which is cosine x hyperbolic sine y plus partial phi partial x. Okay, which means cosine x hyperbolic sine y. Okay, this is gonna make yield a positive cosine x hyperbolic sine y hyperbolic sine y minus. Okay, minus. So what you get here? Minus partial phi partial x. Okay, obviously these two guys, cosine x hyperbolic sine y, are both the same, meaning 0. If you subtract them, you get 0 equals partial phi, partial derivative of phi with respect to x, And what does this give us? Okay, upon integration on both sides, this will produce phi equals a constant. A constant C. Upon further examination and taking phi equal 0, taking phi equals 0, with phi equals 0, a constant, you recall that we actually had V. We had V sine x hyperbolic sine y. Hyperbolic sine plus phi of x. But we have chosen that to be 0. Well, V is a function of x and y, which is minus the sign here. Okay, so we proceed as follows. So this is exactly that. Sine x, hyperbolic sine y, but the phi is already 0. The phi is already 0. So giving us V of x and y, which is minus sine x hyperbolic sine y. Hence, f of z gives us the following. What is f of z at this point? Okay. Right, we first write here plus iv xy, like this. So we have f of z, which equals u. What did we have u of x and y to be as? U of x and y is actually cosine x, trigonometric cosine x plus times the hyperbolic cos y, or hyperbolic cosine y, right? So, which is the cos of y. So this one is the trigonometric cosine of x times the cos of y plus. Okay, we plug in the v, which is actually minus the sine of x hyperbolic sine y, like this. Which means if f of z cos y minus I, the trigonometric sine of x hyperbolic sine y, like this. And now we have answered the question. Let's check if we answered the question full, because we have to find an analytic function f of z, which is a function that equals u of x and y plus iv. So we have done exactly that. Okay, and this is the function that we had to find, and we are therefore done. And thanks everybody, a goodbye to you.